I will try to learn standard integration or with another name, antiderivative, or just the integral. Okay, that is just new topic. The left one is my teacher's professor slides, and the left one is my university's. So I will start at university, and that is the book that we will start in September. So I got this book, so I'm gonna try to study both. So our topic is integral. And if I don't understand anything, I will ask DeepSeek and the AI, because our objection is just learning. So let's dive in. The process of integration. The process of integration reserves the process of differentiation. Okay, in differentiation, if fx equals to 2x squared, then derivative of x equals to 4x. Yes. Thus, the integral for x is 2x squared. Integration is a process of moving from f of x to fx. Yes. So integral is what, as I remember from our last lesson with my teacher. So integration is if we have function like 4x, like derivative of something is 4x. Integral asks what is the original function. Okay, that is the question that integral asks, and with applying integral we will find the original function. So integration is a process of, so integration is a process of summation or adding parts together and elongated as shown as this one. Okay, so integration is summing. So normally s is like this, but it means sum, it means integration, but they do like this. Okay, I get it. Is used to replace words the integral of, hence above. Okay, so integral of 4x equals to 2x squared. So integral and derivatives are the vice versa of each other, we could say. In differentiation, the differential coefficient dy over dx indicates that function of x is being differentiated with respect of x. Yes. The dx indicating that it is with respect to. In integration, the variable of integration is shown by adding the variable after the function integrated. Okay, the variable of, all right, integration. Okay, integral of dx with respect to x. All right, so it means integral of 4x with the respect of x. Okay, I get it. As stated above, the differential coefficient to x squared is 4x, hence. Okay, however, the differential coefficient to x squared is also for x, hence is also equal to allow for the possible presence of a constant whenever the process integration is okay. So differential coefficient of 2x squared plus also this one, 4 is also this one, to allow for the possible presence of the, okay, to allow for the possible presence of a constant when a process of integration is performed, a constant c is added to the result. Okay, all right. So 2x squared plus c, or okay, c is called arbitrary constant of integration. Okay, they are essential notes for us. The general solution of integrals of the form ax n, okay, the general solution of integral form axn, wait, oh my gosh, axn plus 1, so n plus 1, we will write this thing, n plus c, okay. A is our coefficient. The rule when n is fractional, 0 or positive and negative, with the exception of n equals to. This rule is true when n is fractional, 0 or positive, or a negative integer, with the exception of n equals to 1. Okay. I just wanna highlight it. Using this rule gives what? Okay, I think that this part is really enough for us. All right, okay, let's set it like this, because I think for now that will be enough, and I will use other material as well. But now I want to do them using this rule gives. So that is our coefficient, that's x to the power of n. Dx means that with respect of x. That's the way we do integrals. Okay, let's try this one, for example. What is the integral of okay, what is the integral of 3x to the power of 4 dx? So according to our integral rule, it will be like, no, not like this, okay? It will be 3 times x to the power of 4 plus 1 over 4 plus 1 plus c. So it will be like 3x to the power of 5 over 5 plus c. Let's see. That's true. 3 over 5 x to the power. Okay, let's do this one. That was the first one, by the way. So for our integral, that was the first exercise. That is the first one. What about the second one? For the second one, we will have like 2 over x squared dx will be what? It means that integral of 2 times 1 over x squared, or no, not like this, x to the power of -2. Okay, so I remember that in our lesson. I don't know is that if I remember correctly or not, but it's like 2 times x to the -1 2 plus 1 over -2 plus 1 plus c. Okay, like this, and it will be like 2 times x to the power of -1 over -1 plus c. Let's simplify it. It will be -2 over x plus c. -2 over x plus c. Okay, that's true. So let's do this one. Third one. Integral of x under the root dx equals to, that is x to the power of 1 over 2 dx. And what about how to do this? X to the power of 1 over 2 plus 1 over 1 over 2 plus 1 over plus c. Okay, and it will be like what? X to the power of 2, this one, and yeah, like this, plus c, and it will be x 2x over 3 plus c. Is that true? Yes, that's true. That's actually true. You can write either like this or like this. It doesn't really matter. Okay, good job. Each of these three results may be checked by differentiation. The integral of a constant k is kx plus c. For example, 8 what? Okay, the integral of a constant k is kx plus c. Yes, okay, yeah. Because the derivative of this one equals to this one, so okay. I get it. When a sum of several terms is integrated, the result is the sum of the integrals of the separate terms. For example, okay, I didn't know that. When a sum of several terms is integrated, the result is a sum of integrals separate forms. Okay, so if we have this one, dx, it will be like 3x dx, okay, plus 2x squared dx minus 5 dx, like this. Okay, then we will find the integral of all of them. The 3x squared plus 2 times x cubic over 3 minus 5, that will be x over 1 plus c again. Okay, since integration is the reverse process of differentiation, the standard integrals listed in table 37.1. Yes. Oh my gosh. Okay. Wait a second. Not this one, but I need to find PDF. Are you kidding me? It's 370 or something like this. I don't remember exactly, but yeah, like this. Okay. Standard integrals for a to the x to the power of n dx, except when n is -1. Yes, so we have like the rules. The integral of the cosine ax dx. Okay, I just want to note them to my calculus notes over there. So that is calculus 1 in books. There is calculus. Okay, I want to note integral. So our rules, like basically it is ax n dx equals to ax n plus 1 over n plus 1 plus c, except when n equals to -1. Okay, standard integrals. Okay, what about this one? Cosine ax dx. I really struggle with understanding them, by the way, why it's like this. 1 over a sine ax plus c. So if we find sine ax plus c, integral of the sine ax plus c will be cosine Um, cosine ax plus c cosine what? Cosine ax. And d will remove cosine a actually. Okay, I will try to understand it. Like why it's like this. Deep seek. Okay, we have what? Y integral of cosine ax is 1 over a sine ax plus c. Yes. The chain rule in reverse. Because antiderivative, since the derivative of, okay, I will try to understand them from YouTube because it's somewhat complicated for me. I also had the derivative integration, integrand. Okay, dx is x plus c. Okay, we get y is like this, x to the power of n, x to the power of n plus 1. Okay, I get it, but y, oh, this is actually easier than the other one because y 1 over a, I didn't get it. Cosine is sine, and sine is negative cosine. For derivatives, the derivative of cosine x is negative sine x, but for integrals it is like sine x. Okay. Okay, I just want to note it because it is easier than the other one for me. Look, I don't want to write this like this. Cosine x derivative, sorry, integration will be sine x. Let's write all of them. Dx equals to x plus c, integral of x to the power of n dx, x to the power of n plus 1 over n plus 1 plus c, and cosine x will be cosine x dx will be sine x plus c, sine x dx will be negative cosine x plus c, 1 over cosecant, no, cosine dx, sine over cosine is tangent, so yeah, tan x plus c. Okay, 1 over, that will be cotan. Okay, 1 over sine square x dx equals to negative cotangent x plus c. Oh my gosh. Okay, it's easy actually. 1 over x dx equals to negative ln x plus c, and e to the power of x dx, e to the power of x plus c. So I get them like as cosine will be sine will be negative cosine x plus c. Just, but if we have cosine, okay, if we have sine, it will be negative for tan and cosine. Okay, if we have cos value will be positive. What about sine? If we have sine in integral, value will be negative. Result. Okay, if we have cosine, it will be positive. Sine, it will be negative. 1 over x will be ln x. Okay, we know that, but we will write it like this, e to the... Okay, I get it. Properties of indefinite integral. Okay, we need to write them like this. Also for the substitution, it's like this. Okay, a final result property is indefinite integral also satisfy the, which is just restating that integration is the reverse of differentiation. Okay, it is also essential. This one, okay. D over dx, fx dx equals to fx. It means that integration is the reverse of differentiation. Fx. Okay, I don't want to write like this. It's somewhat complicated, but just not it. Okay. Let's write d over dx f of x dx means that integration is the reverse of differentiation. Standard derivatives. Okay, sine is cosine, cosine negative sine, e to the... Okay. I don't know about the ln, by the way, but a sine is... Yeah, I was asking for that. Why it is like this? I just cannot understand why with standard derivatives and standard integrals are like this. But then we have substitution and what? Okay, I just want to understand why it is like this. Okay, standard integrals. That's my problem too. Okay, I don't know why. Why x? Okay, they are same. Let's see. Standard. Explain me standard integrals with standard derivatives in a simple language. Okay, derivative, slope, simple rule. Okay. Okay, we get it, but why? I just cannot understand why 1 over a. It is 1 over a. 1 plus 1 negative a to the power. Okay, let's try to do like, if we say a sine 1 over a sine ax plus c. Let's find its derivative. So 1 over a sine ax will be what? Cosine ax 1 over a times this one plus c. What is the derivative of this one? Firstly, that is the product rule. What is that is a to the power of negative 1 times sine ax plus c. Derivative of this one is what? A to the, like this. Oh my gosh, I forgot derivative because of integrals. But oh my gosh, I forgot it. Are you kidding me? Wait a second. Negative 1. It will be minus, let's say to the power of 5, 4a cubic. How did it? I did this like negative 1 to the power of negative 1 minus 1, negative 2. Negative a, the power of this one, okay, times sine ax plus c. Sine is cosine ax times what? Derivative of ax is this one, just cosine ax plus this one. I hope it's right. I don't know it exactly, and I really cannot understand why. But anyways, okay. So I really cannot understand why it is like the standard integrals and standard derivatives. I will ask this to my teacher. Okay, I really will ask it because I don't know why. Okay, I will ask it. Wait a second. Okay, guys, I asked this to my teacher and I wait his reply. What is next? We have evaluation. Problem 1. Let's try to do problem 1. Even though I didn't understand why some of the things, but anyways, I will try to do. That is more about learning by heart, by the way, the standard integral table. But anyways, let's try to do this one. We had this one. Okay. So we have what? Determine a x squared dx, and then that is a. So it will be 5x cubic over 3 plus c, and b will be 2t to the power of c dt. Okay, it will be t to the power of 4 over 4 plus c. Yes, true. So determine this one. In order to determine, I remember like we need to write them separately, but let me see. 4 plus this one minus negative 6x squared dx it will be like derivative of negative 6x squared dx plus derivative of x plus derivative of 4 dx. So it will be negative 6 x to the power of negative 2 plus 3x to the power of 2 over 14 plus 4x, because derivative of 4x equals to 4, so plus c, I think. Let me see, is that true? 4x plus this one negative, okay, that's true. Problem 3. Even though I didn't understand why that standard thing is like this, I have lost so many time over that, but I will understand it. But till my teacher answer me, I will do them. 2x squared cubic minus 3x 4x dx. I remember that my teacher said me that write this like 1 over 4 times then this equation over x. By the way, I can divide all sides to the x, and it could be like 2x squared 3 like this dx. It will be 1 over 4 times 2 times x cubic over 3 minus 3x plus c, I guess, and it will be like 12 into 1x cubic over 6 minus, I hope it's right. What about the other one? And other one will be like, oh, we have quadrat dt. I think we can simplify it and use the sum rule, but what about, okay, we can write 1 to the power of 3 over plus c, or I don't know, maybe we can simplify it like 1 2t derivative of 1 minus 2t plus t squared. It will be like derivative of 1 plus derivative of negative 2t 1 dx. Okay, 1 dx negative dt negative t dt plus t squared dt. That is 1 t, so t minus t squared plus t cubic over 3 plus c. I don't know which of them is correct, but that's the same thing, isn't it? I don't know. Let me see. Let's check this one. 2x squared. It will be like what? 1 over 6x cubic minus 3 over 4x. What is my 4? I forgot. To, oh my gosh. Okay. So I forgot to write this in. Okay. So this is like, sorry. It is like this. It must be like this, okay? And 1 over 2 times x cubic over, oh my gosh, okay, wait a second, 1 over 4 times 1 over 4 times what? 3 2x cubic over 3, yes, minus 3x plus c. Okay, it will be what? 1 over 6x cubic, x cubic, 3 over 4x plus c. Is that true? Yes. Okay, that's true. What about the other one? T minus. So yeah, we need to write it separately. Yes, yes. Other than this one, t minus t squared. Yes, that's true. Not this one, but this one. Okay, good. What about this one? Determine three over x to the power of 2 dx. Okay, we need to write this like 3 times x to the power of negative 2 dx. It will be 3x plus x to the power of negative 1 over 1. It will be 1 over x plus c. Three. Okay, negative 3. What is this? Wait a second. 3x to the power of, okay, wait a second. 3 times x to the power of negative 2, yes. 3 times x to the power of negative 1 plus 1. Oh my gosh, I forgot one thing. Okay, it's really bad to hurry up here because I made a mistake. It must be like, you know what? Okay, I will not hurry. Alright, I will not hurry. This is 3 times x to the power of negative 2 dx. It will be what? The integral of this one is 3x, yes, times x to the negative 1 plus 1 over negative 1 plus 1 plus c. Okay, it will be 3x times x to the power of negative 1 over negative 1 plus c, and it will be negative 3. There must be something really wrong or not. Okay, negative 3 plus c. No, it's not. Where is my mistake? Why I'm not looking at left side, but I'm just trying to solve it by myself. But okay, wait a second. It is what? 3x. Yes, 3x to the 3 times. Oh my gosh, I made a mistake. Like 3, that must be times. Yes, isn't this times? But I thought it like plus, so it's my bad. 3 times x negative 1 plus like this, negative 1 plus 1 this plus c, and it will be 3x negative 1 plus c. It will be 3 over negative 3 over x plus c. Yes, I get it. Let's do another problem. Integral of 3 dx. Okay, it's easier. Well, let's do this step by step. So it means that 3 times x to the power of 1 over 2 dx. And it will be like 3x 1 over 2 plus 1 over over 1 over 2 plus 1 plus c. It will be like 3 times x. Okay, it will be okay, 2. It will be like what? Yeah, 2x plus c. Okay, that's correct. Let's determine problem 6. -5 over 9. It's easy actually, because we know how to do them. -5, 9 times 4, t to the power of 3 dt. Firstly, we need to simplify everything. What does it mean? It means that we have -5 over 9 times t to the power of 3 over 4. Okay, this is our equation, and we need to simplify this one right now. I hope I will write this correct. -5 power -5 times t to the power of -3 over 4 plus 1 over -3 over 4 plus 1 plus c. Okay, it will be -5 over 9 plus t to the power of 1 over 4 over 1 over 4 plus c. It will be like -5 over 9 plus 4 I hope it's right. I hope it's right. Why I did write like this? Because it's not, yeah, it must be like -20 over 9 times t plus c. Yeah, I think it's like this. -1 over 1 over, yeah, 4 -20. Yeah, that's true. I get it. Good job. That is theta. Okay, let's do integral of 1 plus theta squared over d theta. So we need to simplify everything very well. I could this write like this. 1 plus theta squared plus 2 theta plus 1 times theta to the power of 1 over 2. Okay, it is like this. Okay, -1 over 2. All right, and let's do, okay, what is -1 over 2 plus 2? Three over 2. Yes, I hope it's right. And now we can write it. Theta to the power of 3 over 2 plus 1, 3 over 2 plus 1 over 3 over 2 plus 1, 1 over 2 plus 1, 1 over 2 plus 1, negative 1. Yes. Negative 1 over 2 plus 1 over negative 1 over 2 plus 1. Alright, we have what? 2, 5, 5 over 2 plus theta to the power of 2, 3 over 2 over 3 over 2 plus theta to the power of what? 1 over 2 plus 1 over 2. Okay, I don't know if it's right or not. Okay, it will be like what? 2 over 5 times theta to the power of 5 plus. Yeah. 2 over 3 times theta to the power of 3 plus 2 times theta plus c. I don't know. I don't know really. What is this? 2 times, yes, that's true. 4 over 3. Where is the 4? 2 over 5, yes. 4 over 3. Where is the 4? Okay, I've missed something here. Yes. What is this? 2 negative 2 over 1 plus 2 over 1, 1 over 2 plus. This one is correct. It's going right. That's also right. That's also right. Okay. That's correct. Okay, that there's 2 theta, but I have missed it. Oh yeah. Oh my gosh. Yes, yes. Okay, 2 theta, 2, 2, and that's why it will be 4 over 3. Okay, okay, I get it. I get it. That was a really silly mistake. Okay, let's do them. I think I will have some problems here. Anyways, let's try to do this. Let's try to do this one. So it will be like 4 times. Okay, 4 times cosine will be, we said that cosine is positive, so that will be positive sine. Yes, positive sine 3x times 3x squared over 2, isn't it? Plus c. I don't know. Let's see. Actually, what's wrong? 4 times cosine 3x. Yeah, that I don't understand this one. That okay. Why? Why? Okay, why? Okay, why? That is a rule, but I don't understand this rule. So 4 will be here. Okay, cosine will be sine 3x is what? Cosine 3x. Yes. Normally that is actually like cosine 4 times cosine 3x. And in our derivatives, we generally look cosine 3x, then just that 3x. So 4 times cosine 3x. Cosine 3x is what? Sine 3x for me. Cosine is sine 3x, okay. And what is that 3x? For me, it is like 3x, yeah. That is like 3, what is it? The derivative of, so if we find derivative, that will be 3, but if we are trying to find the 3x, okay, why? Okay, why? If it is like 3x to the power of 2, that is like this for me, okay. I will ask this to my teacher. Okay, 4 times sine 3x. From the table, yeah, that's from the table. And now I will ask it. Oh, okay, that's from the table, I know that, but why? For sine, it will be 1 over a all the time. It is 1 over a. Okay, for if we did it according to that, but I get really tired. Even though, for example, I will do them tomorrow. I studied like 1 hour, about a 1 hour. I got the meaning, but I still have the problem with that cosine and sines, okay? And there are so many things here, and I think that it would be really great if I do them for the next day, because I didn't understand this one, and I don't know, YouTube, I didn't find any video for this, but anyways, so I will just mark the question. So we marked this one, problem 8 here. So we had a problem with standard integrals. That's enough for me for today, okay? But I will study tomorrow, and my charge is low, but I think it's good. at least we studied. So have a good night. Night night.